Hi all, so from the previous video, right now we'll be looking at how to solve exercise questions in exercise 7.1 in the NCERT Math 12 textbook, part 2. So we'll be solving questions from 6 to 22, correct? Okay, so one thing to note here is that I would suggest you keeping a copy of a formula sheet like I have over here, a formula sheet just next to me so that it's easy for you to solve these questions. Remember that these things can be memorized later on. The most important thing is to know how to solve this. Learning the process of solving is much more important than memorizing a bunch of formulas, because a formula can be learned on the last day, few days before the exam, a week in advance. But if you understand how to solve this, you will be set for your exams. Okay, so given that, let's start with the sixth question. Okay, so in this particular exercise, you want to remember that questions from 6 to, all the questions in general is just basic integration. You just have to spread them out. Make sure individual terms are integrable, that they can be integrated, and that's all you have to do. And what do I mean by this? So from our previous introduction, remember I told you an important property, for probability, which is integral of fx plus g of x dx is equal to integral of f of x dx plus integral of g of x dx. Now we will be applying this property as well as the property of integral of k times f of x dx is equal to, bring the k out, which is k integral f of x dx. All you have to make sure is that f of x is integrable, that f of x is in the formula sheet. As simple as that. This is exercise 7.1. So let's start with the first question. Okay. So question number 6, as I said. So integral of 4e to the power 3x plus 1 dx. Now, I think in the previous video I did mention how to solve for e to the power of 3x by the method of inspection. So I think we'll be using that method for e to the power 3x, because in the formula sheet you will be given e to the power x and not e to the power 3x. So I don't think I have it here, but I'll note it down. So as you know, that integral of e to the power of x dx is equal to e to the power x plus c. Okay, so this is the formula, but you don't have e to the power 3x, so we have to use the method of inspection. So now how do you break this down? This is the most important thing. Okay, so let's do this. So integral, so let's break this down individually. We use the first property. So this is f of x, as we can see, and you can consider this as g of x. Okay, the one over here. So now you just integrate them individually. So integral of 4e to the power 3x plus, see, I forgot the dx, so be careful, dx plus integral of 1 times dx is dx. Okay, that's good. Now let's see. Now, how do we integrate for e to the power 3x? That's simple. Now we apply the other property as we talked about. We have a constant here, and we just bring it out. For integral e to the power 3x dx plus, now how do you integrate dx? Okay, so there is 1 times dx. Can 1 be written as x to the power 0? Now, just a side note, whenever you get integral of dx, it's always x. But I'll tell you how this comes. Okay, so over here I can substitute 1. So 1 was here before. So I can substitute 1 as x to the power 0 because anything to the power 0 is 1, right? Dx. So we'll just keep it that way. Okay, so let's integrate this. Now it becomes much simpler. I'm just showing you why the integral of dx is equal to x. So now let's do the method of inspection for e to the power 3x. So how do we integrate that? If you remember from the previous video, the method of inspection just tells us to just differentiate e to the power 3x. So over here on the side, I'm going to do it. So let's move it here. So let's say this comes over here. Okay, like that. Okay, so let's do this. So e to the power 3x d by dx, so you differentiate this, which is equal to what? So how do we differentiate this? Simple. E to the power 3x, and then because 3x is on the power, you differentiate 3x. You differentiate 3x times, what is the differential of 3x? 3. Correct. So therefore, d by dx, now you want to isolate this 3x, e to the power 3x. So you take 3 to the other side, which is d by dx, 1/3 of e to the power of 3x, and is equal to e to the power 3x. Now this, let me use a different color, this is your integral value. This is the integral value. If you don't know the method of inspection, watch the previous video. Towards the end, you'll kind of get an idea of what the method of inspection is. Okay. So now, since this is the integral, I can just substitute it back here. So it's 4 times, as you see it, 1/3 of e to the power 3x plus, now what is the integral of x to the power 0? Simple, right? You add 1 and you divide by 0 plus 1. Very simple, correct? So this would be x raised to the power 0 plus 1 is x, divided by 1 is x. Now, of course, each of them has their own c, but overall the constant adds together to this, right? You just put a plus c at the end. Individually, they have their own plus c, so you can think of it this way, as in, wait, yes, as in, this is plus c1 plus x to the x plus c2, correct? So let's do this again. This is the integral value of this. This is the integral value of this, and I'm adding them together. Okay, now what I can do is I can say c1 plus c2 is equal to c, because eventually they're going to add to some constant value, correct? So what I do is I simplify this. So now it's 4 by 3 because 4 times 1/3 is 4/3. E to the power 3x plus x plus c. So this is your answer for the 6th question. Okay, great. I hope you all got this. So let's move on to the second one, the 7th one. Sorry. So I'll just Ever. Let's see how long this takes. Okay. So let's move on to the next question. So the second question, x squared plus x squared. Okay, this is interesting. So now we have the seventh question, which is x squared times 1 minus 1 over x squared. Interesting dx. Now, all we have to do is we have to make sure that we have every single value being integratable. So I'll just multiply this. I'll remove the brackets or open the brackets as you would say it. So x squared times 1 is x squared. And x squared times 1 minus 1 over x squared. I'll do the whole thing. So it's x squared over x squared, which is basically 1. So I know this is 1. Just going to replace it. This is minus 1 times dx. Correct? In simplified form. Now, ask yourself, between all the additive values, or between the sign, after every sign, are they integratable? Is x squared integratable? Yes. Is 1 integratable? Yeah, kind of, because as you know, 1 times dx is x. The integration of dx is x. So by just looking at it, I know now it's integratable. Okay, so let's integrate this. Okay. So I will integrate this. Wait, the question doesn't ask for dx. I'm sorry. Okay. My apologies. Okay, so let's integrate this. Again, same, apply the same properties. You have two elements that are being subtracted, integrate the individual elements, and then subtract them. Okay, so let's integrate this. So integral of x squared dx minus integral of dx. Right? So this is integratable, which is x cubed over 3, remember, again, plus 1 divided by 2 plus 1. Okay? Now, minus integral of dx is x. Okay? Now, each of these have their own constant, and they all add up to c. Correct? So we got that in check. Now, next question. Now, ax squared plus bx plus c. Okay. So, ax squared plus bx plus c. Now, all you have to do, again ask. So, you have 3 elements added together. Are they integratable? Is this integratable? Yes, it is. Now, a lot of people see a and get scared. A is a constant. Remember that, it's a constant. Just like 2, 3, 4 treated it as the same way. A can be a real number. It's a constant variable. As simple as that. Okay, it is not f of x, it is just a constant value. Okay, so think of it as a real number, a random real number. Then you have b of x, yes, integratable. C is also just a constant, integratable. So given that, what I can do now is I can integrate the individual elements. So integral of ax squared dx plus integral of bx dx plus integral of c dx. Now this gives you that k property, right? So the property, if you remember what the property was, integral of k f of x dx is equal to, you bring the k outside because it's a constant value, k integral of f of x dx. Apply the same thing. So beforehand, tell me what comes out in all of the elements before the integral. If you said a, b, and c, you're absolutely right. So a should come out, b should come out, and c should come out. Very good. So a x squared dx plus b integral x dx plus c integral of dx. Now what is the integral of x squared dx? Correct? Simple. We did this again. So this is a times x cubed over 3 plus b times, what is the integral of x? B times x squared over 2 plus integral of dx is x. C times x. Now each of them have their own constants, c1, c2, c3. It all adds up to c. Okay? So this should be your final answer for question number... Oh, this is question number 8. I'm sorry, I forgot to change here. So this is question number 8, and this should be your answer. All right? Okay. Now moving on to question 9. Let's go on to question 9. So let's delete this. Okay. Okay. Question 9 is... Sorry. Okay. Question 9. Integral of 2x squared plus e to the power x. Correct? So, how do we solve this? Simple. Are they integratable? Yes, both elements are. So, we follow the same procedures. Integral. Now remember, okay, let's go the long way. Sorry, dx. See, I tend to forget it as well. Okay. Plus integral of e to the power of x dx. Now this has a constant, and so this will come up. So 2 integral of x squared dx plus integral of e to the power of x dx. Now we know this is 2 times x squared dx is, you add 1, divide by the whole thing. So 2 times x cubed over 3 plus integral of e to the power of x is always e to the power of x. So e to the power of x plus c. As simple as that. Okay, so let's move on to the next one. Question number 10. Question number 10. This one is very interesting. Okay. It is quite easy, it's not that difficult. So integral of square root of x minus 1 over square root of x, the whole square dx. Now, if you think you can, now you have to expand the square, open the brackets, right? So as simple as that, let's do this. So let's open the bracket, so integral. So what is, so square root of x, the whole square, a square, minus 2ab, 2 root of x, times 1 root of x, plus b square, which is 1 by root x, the whole square dx. Correct? So let's integrate. Integral of, what is, so the square root of x squared becomes x, minus, now root x and root x gets cancelled because they're dividing each other, minus 2, plus 1 over root x the whole square is 1 over x, correct? Because 1 squared is 1 and 1 root x squared is x dx. So let's integrate them individually. So now you ask yourself, all the three terms integratable? X is, 2 is definitely, and 1 over x is. So let's do this. So integral of x dx minus integral of 2 dx plus integral of 1 over x dx. Okay? In fact, let me make this 1 over x dx, which is equal to, so how would you integrate this? What is the integral of this? Is exactly x squared over 2 minus, now 2 dx is what? Correct? 2x plus, what is the integral of 1 over x dx? So it isn't there in my formula sheet, but if you definitely look at your formula sheet, it is just log of x plus c. Now be careful, because sometimes you might think that integral of 1 over x is equal dx is equal to integral of x minus 1 dx. Now you can't apply add 1 and divide by n plus 1, because that would result in the value being infinity. And if you see in the formula even, correct? Look at the condition. This condition can only be applied if n is not equal to minus 1. So be careful about that. Okay, there is a separate formula for x raised to the power of minus 1 or 1 over x. And that is log of x. Alright? Okay. So now we're done with the 9th. Let's do the 10th. I think we're getting a hang of this. I guess everyone is. Please let me know in the comment section if you do understand my method of teaching, or you need more information or more steps. Just let me know what's your level up, so I can help you out, so I can make better videos in the future. So we're on the 10th question. I did the 10th question. Okay, I did the 10th. I'm sorry. I think I didn't mark it as the 10th in the previous, but anyways, I've done the 10th. Okay, let's do the 11th one. So 11th one. Okay, interesting. So now x cubed plus 5x squared minus 4 over x squared dx. Correct? Now you might be thinking, okay, we're dividing two things. How do I find this? This is interesting. How do I find the integral of this? A bit confusing, because you were seeing individual terms. Now you just apply the property of fractions, which is x squared is basically divided with each and every single term. Correct? So what I can write this as, so the same thing can be written as integral of x cubed over x squared plus 5x squared over x squared, because they have the same base, same denominator, minus 4 over x squared. Both of these terms are equivalent. Correct? Both of these terms are equivalent. Correct? Because all of them have the same denominators. Okay. Dx. Now, we apply the law of exponents. So whenever you have the same base as in here, so x is in the first element, the base is x, but the powers are different. So you subtract because you're dividing them. So 3 minus 2 is 1, so it is integral of x, okay, plus, correct? Now, of course, if you know this cancels out, x squared and x squared gets cancelled, so this is 5. And this, of course, becomes, you take x to the top. If you take x squared to the top, the power becomes negative, correct? So x minus 2 dx. So let's integrate every single term. Now, are the terms integratable? See, here is -2, but it's not -1. So you can apply the formula for x raised to the power n. So integral of x dx plus 5 integral of 5 dx minus integral of x raised to the power -2 dx. Simple, which is equal to x squared over 2 plus 5x minus, now this is interesting. How would you do this? So let's do this. Let's see. Now this is important because the sign is also very important. Okay, so this is, now if I were to integrate -2, this would become +1, and this would be -2 plus 1. So therefore the sign changes, right? So in this case it makes the sign change. Okay, because you will get a value of, you will get minus, okay, let's make sure that we are on the same path, x raised to the power -1 divided by -3. No, I'm sorry, -1. Sorry, -1, correct? -2 plus 1 is -1. Okay, now of course the negative sign will change this sign to positive, so that will, so the final answer would be x squared over 2, this would be plus c, sorry, plus 5x plus what, x raised to the power -1 plus c. Or you can write it as x squared over 2 plus 5x plus 1 over x. Remember, x raised to the power -1, I can bring it down, plus c. Either ways, both are correct. You don't have to worry about that. Both are correct. Both are correct in terms of their solution. Wait, did I make a mistake? Oh, I forgot the 4. I am so sorry. Wait. Did I make... Yes. I forgot the 4 here. I am so sorry. The constant. So even I make mistakes. So when I integrate this, I should have been careful about that. This would have come out 4. So this is 4 times. Correct? I am so sorry about that. 4. Exactly. See? So this will become 4. Correct. Sorry, I forgot to multiply the 4. That's it. Okay. 11. Now let's look at the 12th question. Okay. So let's look at the 12th question. So integral of x cubed plus 3x plus 4 divided by root x dx. Okay. This is quite interesting. This is quite an interesting example also. I think this part, the only tricky part is the root x, because I think you can see that you can divide each element. Now all you have to do is root x can be substituted as x raised to the power half. Okay, and you always have to remember this. So if it is cube root, is x raised to the power 1/3. What if I said something like this, meaning you take the root twice, is x raised to the power 1/4. Simple as that. Okay, so I think that was easy. Okay, all you have to do is 12 integral of x cubed over, x raised to the power half plus 3x divided by x raised to the power half plus 4 divided by x raised to the power half dx. Now let's, in terms of integrate each of these terms, so what would this be? So 3 minus half. What would be 3 minus half? That would be 5 over 2, if I'm not mistaken. So 3 minus half is, so let's do it here, 3 minus half, of course, multiply by 2, which is 6 minus 2. No, this you don't have to multiply. I'm sorry, you multiply by 2 and multiply by 2, sorry, 6 minus 1 divided by 2, which is equal to 5 over 2. Okay, so this would be integral of x cubed minus half. Okay, so you subtract these two, and that would result in something like this, 5 over 2. Okay, plus 3. So what is, so this is 3x to the power 1 minus half. So 1 minus half is negative half, right? No, it's still half, sorry. Why am I saying that? Sorry, it's half. Plus 4. Now, remember, you're taking x to the power half up, so this becomes negative half dx. Correct? Now you can integrate these terms. These are very easy to integrate, but let's do it together. So I will not expand it now. Integrate this times this. Oh, let's do it anyways. That's fine. X to the power 5 by 2 dx plus 3x to the power of half dx plus 4x to the power minus half dx. Correct? Sorry, the integral sign. Okay, so how do we integrate? We add 1 to it. So let's add 1. So add 1 to this, divided by 5 by 2 plus 1. Again, add 1 to this, 5 by 2 plus 1. Remember, the constant, we just bring it out. You know this, bring it out. This plus 1 divided by minus half plus 1. Correct? That would be the integral value. So let's do that. So what is 5 by 2 plus 1? So that would be 7 by 2. So I would have x raised to the power 7 by, let's make this simpler. Okay, I'll start from here, so that's easy. X raised to the power 7 by 2 divided by 7 over 2. Okay, plus, so half plus 1 is 3 by 2, right? So the 3 comes out times raised to the power 3 by 2 divided by 3 by 2 again. I think I did a mistake here, I'm sorry. Yeah. Sorry about that. This is half plus 1. Correct, that's correct. So that is correct. Plus, again, 4 times. So minus half plus 1 is half. So raised to the power half divided by half. Plus c, right? Now let's simplify this. Now if 7 by 2 is in the denominator, and if you want to bring it here, you have to take the inverse, which is 2 by 7. So 2 by 7 times x raised to the power 7 by 2 plus, again, 3 by 2 is in the denominator. If you want to bring it here, you invert it, which is 2 by 3 times oh, this is x. I forgot to write the x. My bad. Okay, I'm sorry about that. So 2 by 3 times 3, correct? Times 3 x raised to the power 3 by 2, correct? Plus, now if you're bringing half here, it inverts again. 2 by 1, which is 2 times what? Why do I forget to write the x? I'm sorry. Forgot to write the x there as well. 2 times x raised to the power half. 2 times 4, sorry, x raised to the power half. Now this 3 cancels, this 2 becomes 8, so the final value is, sorry about that, that would be 2x cubed, and this would be 8x half. This would be your final answer for question number 12. Okay, and of course the plus c, never forget that. Now x raised to the power half, you can write it as square root of x. That's totally up to you whether you want to write it or not, but this would be the final answer. Okay, okay, so let's go to question number 13. 13 is quite interesting. Let's see as well. So question number 13. Okay, integral of 1 minus x square root of x dx. Now again, square root of x, as we all know, is x raised to the power half. So let's multiply that. So that would be integral of x raised to the power half minus, now this is 1, so 1 plus half is 3 by 2. Correct? X raised to the power, because x times x to the power half is x raised to the power 1 plus half. So this is 1. You add the powers, which is x raised to the power 3 by 2. Correct? And I think you can integrate from here. It's quite simple. So I'm not going to waste your time and integrate this. Or let's just do it really quick. Okay, so let's do this quick. So integral of x to the power half dx minus integral of x raised to the power 3 by 2 dx. Alright, so integrate this again, like I said, plus 1, half plus 1, plus 1, 3 by 2 plus 1. Correct? So let's do that. Let's integrate it. So half plus 1 is 3 by 2, so x raised to the power 3 by 2 divided by 3 by 2 minus x raised to the power 5 by 2 divided by 5 by 2 plus c. Right? Now if you bring this up, or if you bring this up, you invert it. Right? So 2 by 3 times x to the power 3 by 2 minus 2 by 5 x to the power 5 by 2 plus c. If I'm not... Okay, I'm sorry, this was the 14th question. My bad. This was the 14th question. I saw it the wrong way. So we were doing the 14th question. Okay, so this should be the right answer. Okay. Let's go to the 13th. The 13th is very important. That's a bit tricky, but if you find the trick, then it's very easy. Okay, so let's do the 13th, sorry. So let's do the 13th question, which is x cubed minus x squared plus x minus 1 divided by x minus 1. Now, this might throw you off and you might think, okay, how am I going to divide this? X cubed, should I divide each of them divided by x minus 1? But then I don't see myself cancelling anything or subtracting the powers. So interesting, right? But what I can see is I can group two terms together, right? What if I grouped two terms? Could there be a possibility of cancellation? Well, if I group these two terms, yes, I could cancel x minus 1 and x minus 1. But what about these? Correct? Now, interestingly, both of them have a common factor x squared. And these two terms, common factor is x squared. So I can take that out. So let's do that. So, I'm sorry. Integral dx. Okay. So what I can do is I can separate these two terms individually, which is x cubed minus x squared divided by x minus 1 plus x minus 1 divided by x minus 1 dx integral. So this goes to 1. That was very easy. Now what about this? So let's take out x squared as the common factor. So x squared times x minus 1 divided by x minus 1 integral plus 1 dx. Correct? So x minus 1 cancels, and therefore your new integral sum is x squared plus 1 dx. And I think this is pretty easy. I think everyone will do it, so I'm not going to do this for you. I think this is the most important thing, and if you can see that, that's it. So whenever you have a base of x minus 1, whenever you see this, quite simple, is just try to see if you can factorize it or make it even smaller. Simplify the equation. That's what I meant. If you can simplify the equation, you get a better outcome in which you can integrate the sum of the function. So in this case, from x cubed minus x squared plus x minus 1 the whole divided by x minus 1 reduced to x squared plus 1. Okay, and this is easier to integrate than it is to integrate this. That's it. So I think you can all integrate this. We'll move on to the next question. Okay. So let's go to question number 15. 15 is the same as 14, so I'm not going to do that. That is pretty simple. It is the same thing repeated. If you want, just check before question number 13. I did question 14 before 13, so my apologies on that. Question number 16. Okay, question number 16 is also pretty easy. Let's do that. So 16. Integral of 2x minus 3 cos x plus e to the power of x dx. Okay, interesting, right? So what do we do with this question? Is each of the terms integrable? So let me just do this. I think this is okay. Each of the terms is integrable, right? So 2x is cos x. You have cos x, remember. Integral of cos x is sin x, quite simple. And e to the power of x, you know what it is, right? So you can do this directly in your head as well. Like, I don't have to go through every single step. But remember, for your exams, you want to do that, right? You want to make sure that you write integral of cos 2x dx minus integral of 3 cos x ex dx, correct? Now, obviously, take 2 out, take 3 out, and integrate the terms. So what is the integral of x? X squared over 2, you know that, minus integral of cos x is sin x, so sin doesn't change, so this is 2 times 3 times sin x plus e to the power of x becomes e to the power of x plus c. Correct? How simple was that? So that was question number 16. Now 17th. 17th is relatively the same. You just have, it's the same thing. Now 18th. 18th is a good question. 18th is something we can all do. Is something new. So let's try question number 18. So 18. integral of secant x times secant x, sorry, no, it's, yeah, plus tan x dx. Okay, so let's simplify. Integral of secant square x plus secant x tan x, right, dx. Now check if the individual terms are integratable. So as you can see, if you see here, you have a formula for secant square x, and you have a formula in the formula sheet, you have a formula for secant square x and secant x tan x, right? So simply reduces down to integral of secant square x dx plus integral of secant x tan x dx. Now what is the integral of this? Of course is tan x plus secant x tan x is what? Secant x plus c. As simple as that, right? That should be for question number 18. So tan x plus secant x dx. Now question 19. This is interesting. This is very interesting. I like this one. This is going to broaden your horizon a bit. Okay, so now integral of secant square divided by cosecant square x dx. Correct? Now the thing is, how would do you have a formula on the formula sheet for this? I don't think so. So I think this requires some form of simplification, right? If I'm not mistaken, this requires some form of simplification. So what could we do to simplify this? Sorry. How would we simplify this? Correct? How would we simplify this? Okay. How do we simplify this? Now what I like to do, in my personal opinion, I don't like secant and cosecant usually. I generally go for something like cos and sine because they're quite familiar to most of us. And before we go ahead with this, you must remember a few identities, which is sine x divided by cos x is equal to tan x. Okay, this is the most important identity. Now, if you invert this, meaning if you invert this and bring this down, okay, you also have to invert this equation, right? So cos x by sine x is equal to 1 over tan x. Now what is the inverse of tan x? Cot, right? So cos x over sine x is equal to cot x. Usually I stick to this because from this I can derive this, so it's pretty easy. So what is secant? How do I make sure that I can write this in terms of sine and cosine? Right, so what I do is secant square is 1 over cos square x. Correct? And this is divided by, now I can, cosecant is basically the inverse of sine. So I know that is equal to 1 over sine square x. So remember this identity as well. So this is important. This as well is important. This is also 1 over sine x is equal to, and 1 over cos x is equal to secant x. Alright. Similarly, if you take the inverse of cosecant, so 1 over cosecant x is equal to sine x. 1 over secant x is is equal to cos x. Okay, so I want you to always keep this in mind. These are very important things. These are important trigonometric identities. Okay, so anyways, like I said, so you want to integrate this with respect to dx. Now, how would you integrate this? Correct? We still have to simplify it. So how would this become? So let me show you some basic math again. So 1 over cos square x, okay, divided by 1 over sine square x. Need some space. Let me take this and move this maybe over here. Give it some more space here. Move it here. Okay, sorry about that. Okay, you can just take this. Okay, so let's divide these two. So this is basically the same representation, right? Now remember, when you divide two fractions, what you can do is you can take the inverse of the second and multiply it. So this basically becomes 1 over cos square x times the inverse of this, which is sine square x, by 1, which is 1. So this is what? Sine square x divided by cos square x, which is equal to tan square x. Right? So this basically becomes integral of tan square x dx. And what is this equal to? Do we have a formula for tan square x? We don't. We have secant square x. Right? Now that is important because remember the identity. Right? So I'm going to delete this. Okay? Okay? Remember the identities, your trigonometric identities. This is important. Alright? Okay. So you remember what was it called? Was it secant square x? Let's figure it out. Okay. Sine square x plus cos square x is equal to 1. Now if I want tan, I have to divide the whole thing by 1 by cos square x, right? The whole equation. So sine divided by cos, tan square x again, plus cos square divided by cos square is 1. 1 divided by cos square, as we all know, is what? Secant square. And tan square x is equal to secant square x minus 1. Simple, okay? So integrate secant square x minus 1 dx. Now this is simple. You can integrate secant square and you can integrate dx. So quite simple, not too complicated. Let's solve for it. So I'll just remove this whole thing. Delete. Okay. So let's integrate this. So integral of secant square x dx minus integral of dx. Right? So what is the integral of secant square x dx? Tan x. Very good. Minus, what is it? Integral of dx is x plus c. There you go. Right? Simple. Very simple. So now let's go in for... Okay, so let's... Okay. Okay. Let's go for the next question, which is question number 20. 20 is also a bit tricky, I would say. Just practice these questions, 19, 20. I would say particularly practice questions number 11, 12, 13, 15, and 18, 19, 20. These are quite tricky questions. These are the questions that will, if you know to do these questions which I've mentioned, which I've mentioned, I'll mention it at the end. You're basically set for this exercise. You don't have to worry about anything else. Okay? So let's do question number 20. So 2 minus 3 sine x divided by cos square x dx. Now again, this is simple. This is actually very simple. Each term divide by it. So integral of 2 by cos square x minus 3 sine x by... Now here's what I'm going to do. Instead of writing cos square x, I'm going to write cos x times cos x. Okay? We'll see why. The same thing. I've just broken down the terms. Dx. Now, the inverse of cos square x we know is secant square x. So 2 times secant square x. So we brought cos square x to the top. It becomes secant square. Because we know 1 over cos square x is equal to secant square x. Correct? Now, let's take these two terms. So, like we said before. So what is sine divided by cosine? Okay? And then we have cosine as one of them. So this can be written as minus 3 times 1 over cos times sine over cos. Correct? Correct? Which basically means this is integral of 2 secant square x dx minus integral of, now 1 over cos is what? Secant. We know this. Just take the square roots over here, both sides, you will get it. So that would be secant x tan x dx. Now we have the formula for these, right? In the formula sheet. So secant x tan x, we do. So what is the integral of 2 times secant square x? It's tan x. So we have tan x minus, what is secant x tan x? Secant x plus c. Simple. Very simple. Now if you're worried about if you don't know the formulas, don't worry about the formulas. Okay, the only thing I would want you to recognize is just the trigonometric ones. Right? Cos and sine is obvious, but these four in particular, you must be able to recognize them. Okay, you must be able to say, okay, there is an integral value for secant x tan x. There isn't a value for, there is an integral value for secant square x, but there isn't an integral value for tan square x. So you have to be aware of that. If you're aware of that, everything sorts out by itself. You don't have to worry about anything. All you have to do is just make sure you can identify. You don't have to know what the exact formula is. You can identify and go back to the formula sheet. That is the most important thing in this subject. Now, questions 21, easy. Okay. Questions 22. Question 22. This is a very good exercise. This one is pretty good. So, give me a moment. Okay. Question number 22. Okay, something is wrong. Okay, sorry. Something was wrong with my pen. Okay, so let's delete this. Now let's see question 22, which is an interesting question. So if d of dx. Okay, so if the differential of f of x is equal to 4x cubed minus 3 divided by x power 4 such that f of 2 is equal to 0. So f of 2 is equal to 0. Okay. Then you have to find f of x. So you have to find f of x. Now, what do we have to do here? This is a very interesting question because this equation itself should tell us everything, right? Let me put this here so that it's easy for us to view. Okay. So now this is the given. This is the given. So we know f of 2 is equal to 0. We have to find f of x. Okay. Now, what if I integrate on both sides? If to get f of x, I just have to integrate on both sides, because if I integrate, it removes the differential, right? Because the integral and differential cancel out each other because they're opposites of each other. So integral of d by dx f of x, sorry, this doesn't look like whatever, okay, is equal to integral of 4x cubed minus 3 by x to the power 4. Correct? And so this thing cancels. So I'm left with f of x. So f of x is basically the integral value. Correct? Which is equal to, let's integrate. Sorry, forgot the dx, my bad. Okay. So f of x is equal to what? Integral of 4x cubed dx minus 3 by x to the power 4, sorry, integral dx. Now you know how to find this, so this can be written as, so what is the integral of x cubed is integral of, sorry, is 4 times, this comes out, integral of this is x to the power 4 divided by 4, that cancels, minus, now this can be written as the same as 3 times x to the power of minus 4. So let's work on this. So what is minus 4 plus 1? Minus 4 plus 1 is minus 3, right? So you get 3 times, of course the 3 comes out, x raised to the power minus 3 divided by minus 3. Now because this is negative and this is negative, this becomes, of course, cancels and becomes positive. Right? If I'm correct. Okay. That becomes positive and this becomes plus c. Now again, the 3 gets cancelled. So what you're left with is x to the power 4 plus x raised to the power minus 3 plus c, or you can write x to the power 4 plus 1 by x cubed plus c, because the negative, if you bring it down, becomes positive. So see, let's see which answer looks like that. So x raised to the power 4. Did I do a mistake? No. Okay. Plus c. Now, an interesting thing is that what is f of x? Now, the thing is, the f of x has a constant value. Correct? We got the integral value, right? Now, if you remember, the given was f of 2 is equal to 0. Okay, so let's solve for this. F of 2 is equal to 0. Correct? So let's do that. So we know this is f of x. So let's substitute. So we know that f of 2 is equal to 0. So let's solve for that. Now f of 2 is equal to what? So I have to substitute here. So x, so 2 raised to power 4 plus 1 by 2 raised to power 3 plus c. And this whole equation is equal to 0. So let's solve for this to find c. So what is 2 raised to the power 4? 16 plus 1 by 8 plus c is equal to 0. Right? So let's do this. Let's solve for this. So c is equal let's add this up. Okay, so 16 plus 1 by 8 is, let's just isolate first. So 16 minus 1 by 8. Let's solve this. So you can multiply by 8. And let me make this simple. You have to make them like fractions. So if you put 8 here, you have to multiply 8 here. So what is 16 times 8? Let's do it quick. 6 8s are 48. 8, 12, 128. So we've got minus 128 minus 1 divided by 8, which is equal to minus 129 divided by 8. So we got a C value. Now all we have to do is take this C value, okay, this C value, okay, remember this was our previous answer for f of x, remember this whole equation f of x, sorry, this equation, and all we have to do is substitute the value of C in here. Okay, so now what does that mean? So therefore my f of 2 is equal to, wait a second, I'm sorry, my f of x basically is equal to, okay, x to the power 4 plus 1 by x cubed. Now we know what the constant value is, minus 129 by 8. And so the answer is option number A. I guess it's A, correct? Yes, option A. So option A in your textbook should be the right answer. Okay. So did I make a mistake anyway? No, I didn't. Okay. So this is correct, option A. Alright, so that was exercise 7.1. I hope you guys understood everything. I hope this was quite intuitive for you. You've learned something new out of this. If you feel this helped you, like, share, subscribe, hit the notification bell, and most importantly, comment down what do you want next. How did I teach? If you want a better form of teaching, do let me know in the comments. Have I missed out on anything? Did I make a mistake? It'll help others to figure it out as well. And also, if you're watching this, do read the comment section yourself and see where people are having doubts. You could help them out if you know the answer, and most importantly, if there are mistakes, someone will point them out, and that could help you in one way or the other. So thank you for your time, and don't forget to like, share, and subscribe. Thank you.